Light has no mass. Zero. None. Weigh a photon and you get nothing. And yet, light pushes things. Right now, sunlight is pressing against the roof above your head, gently, constantly. Photons are shoving satellites off course. NASA has to account for this. Light is literally moving spacecraft across the solar system. Wait, momentum requires mass. That's what you learned. That's what makes sense. A truck has momentum because it has mass moving fast. A bullet has momentum. A thrown rock has momentum. Mass times velocity. Simple. So how does something with zero mass push? Most people think momentum is about weight in motion. Heavy things moving carry force. Light things carry less. Nothing carries none. That belief is not a little wrong. It's fundamentally wrong. Here's the wow fact. NASA is currently developing spacecraft that use no fuel. None. They unfold giant reflective sails and let sunlight push them to other planets. The pressure is real, measurable, exploitable. Massless light. Real momentum. Real force. This isn't a metaphor. This isn't poetry. Your phone flashlight is pushing against whatever it shines on right now. You just can't feel it. And once you understand why this works, it changes how you see energy, mass, and what motion even means. Let me show you. Grab your phone. Seriously, do this right now. Turn on your flashlight. Point it at your palm. Hold it close. Feel anything? Nothing. Warmth maybe, but no push, no pressure. Here's the part your physics teacher skipped. That light is pushing your hand, right now. Every photon hitting your skin is delivering momentum, transferring force, shoving against your flesh. You just can't feel it because the push is absurdly small. We're talking billionths of a Newton. Your hand experiences more force from a single floating dust particle landing on it, but small isn't zero. And when you add up enough photons, when you scale up to the size of the sun, beautiful. The sun releases 400 trillion watts of light every second. That light carries momentum. That momentum spreads across the solar system, and everything it touches gets pushed. Your phone flashlight is a weak echo of this, a whisper of the same force. Now here's the thing. You've been told momentum equals mass times velocity. Multiply how heavy something is by how fast it moves. That's momentum. Every physics class teaches this. Every textbook prints this formula. People say that's how momentum works, but that's just a label. That formula, it's the baby version, the training wheels equation. It works for baseballs and cars and planets, things with mass, things moving slower than light. But light doesn't play by those rules. Light has no mass. Light always moves at maximum cosmic speed, and light still carries momentum. So either momentum isn't what you think it is, or mass isn't what you think it is, or both. Spoiler, it's both. The universe keeps strict books. Energy cannot vanish. Momentum cannot disappear. These are non-negotiable. The cosmos will bend space and time before it lets the accounting fail. And light? Light is pure energy in motion, no mass required, just energy moving through space-time at the universal speed limit. That energy carries momentum. Hold that thought, it gets stranger. Because the equation you know, E equals mc squared, that's not the full equation, that's not even close. E equals mc squared. You've seen it on t-shirts, coffee mugs, tattoos. It's the most famous equation in human history. And it's incomplete. Einstein never wrote just that. That's the simplified version, the headline, the clickbait of physics. Here's the part nobody tells you. The real equation has two parts. Energy squared equals momentum squared times the speed of light squared, plus mass squared times the speed of light to the fourth power. Sounds complicated. It's not. Think of it like this. Energy has two sources, two parents, momentum and mass. Both contribute. Both feed into total energy. For things with mass, like you, like a car, like a planet, both parts matter. Mass contributes, momentum contributes. Add them together and you get total energy. But what happens when mass equals zero? Simple. The mass part vanishes, disappears, gone, and you're left with just momentum. Energy equals momentum times the speed of light. That's it. For light, energy and momentum are married, directly linked. You cannot have one without the other. A photon carries energy, then it carries momentum. Period. No negotiation. This is where your intuition completely fails. We think mass is required for momentum because we live in a slow, heavy world. Everything around us has mass. Rocks, water, air, our bodies. People say momentum needs mass, but that's just a label. Momentum doesn't need mass. Momentum needs energy in motion. Mass is just one way to carry energy. Light found another way. Think about what just happened. The equation you learned, mass times velocity, that's a special case, a shortcut. It works when things have mass and move slowly compared to light. But the universe runs on deeper rules. The real rule? Energy and momentum are connected, always. If something carries energy and moves through space, it carries momentum, whether that something has mass or not. Brutal. Light carries energy. Obvious. You feel warmth from the sun. You see because photons deliver energy to your eyes. Energy is there. And if energy is there while moving, momentum follows. The universe doesn't care what feels right. It cares what balances. Energy in, momentum out. The books must close. Reality doesn't issue refunds. So when a photon hits your phone screen right now, it delivers energy. That energy was moving. So momentum transfers. Your screen gets pushed. Billionths of a Newton, but pushed. Now watch what this actually implies. If light has momentum, light can do everything momentum does. Push things, move objects, transfer force. And somewhere out there, engineers figured out how to use this. They built sails for sunlight. Let me give you an analogy. Imagine a briefcase full of cash. You put it on a scale. The scale shows weight, leather, paper, metal clasps, mass. Now imagine the cash inside is digital, a number on a screen. The briefcase is empty. You put it on the scale, lighter. But here's the thing, that digital money still has value, still transfers when you hand over the briefcase, still changes ownership, still moves economies. The value moves, the weight doesn't. Light is that briefcase, no mass on the scale, but packed with value, packed with energy. And when it arrives somewhere, that value transfers. This is the part that broke Einstein's brain too. See, before Einstein, everyone thought light was a wave, just a wave, rippling through space like sound ripples through air. Waves don't push things, not really. They disturb, they oscillate. But momentum, force, that's for particles, bullets, objects. Then Einstein looked at something called the photoelectric effect. Hold that thought. When light hits metal, it kicks out electrons. Simple experiment. Shine light on metal, electrons fly off. But here's what's wild. Dim red light, nothing happens, no electrons. Crank up the brightness, still nothing. But dim blue light, electrons everywhere. Wrong. That makes no sense if light is just a wave. Brighter should mean more energy. More energy should kick out electrons. Color shouldn't matter. Unless light comes in packets. Tiny discrete bundles of energy. Each bundle has a specific amount. Blue bundles carry more than red bundles. It's not about total brightness. It's about energy per packet. Einstein called these packets quanta. We call them photons. And each photon, each packet, carries momentum. The universe keeps meticulous books. A photon arrives with energy. That energy came from somewhere. It was moving at light speed. Momentum was encoded. When the photon stops, absorbed by your eye, your skin, a solar panel, that momentum has to go somewhere. Light doesn't negotiate. It delivers. Always. The energy deposits. The momentum transfers. The target moves. You can't see it with your hand. The photons are too weak, too few. But what if you collected millions of them? Billions? Trillions? What if you built something designed specifically to catch that momentum? Here's where it gets uncomfortable. Because we did. And it changed spaceflight forever. The year is 1905. A 26-year-old patent clerk in Switzerland is about to break physics. His name is Albert Einstein. He has no lab, no university position, no research budget. He works a desk job reviewing other people's inventions. And in his spare time, he dismantles reality. This is the part that rewrites everything. In one single year, Einstein publishes 4 papers. Any one of them would have made him legendary. Together, they reconstruct the foundation of physics. But there's one paper nobody expected. Not relativity, not E equals mc squared. The photoelectric effect. Here's the setup. Scientists had known for years that light hitting metal produces electricity. Shine light on certain metals, electrons pop off. Useful, weird, unexplained. The problem? It didn't follow the rules. People say light is a wave, but that's just a label. If light was purely a wave, brighter light should eject faster electrons. More energy in, more energy out. Simple. Except that's not what happened. Brighter light ejected more electrons, but not faster ones. The speed depended on color. Blue light made fast electrons. Red light made slow ones. Sometimes red light made 0 electrons no matter how bright. Wild. Nobody could explain it. The wave theory of light, 200 years old, battle-tested, couldn't handle this. Einstein looked at this mess and saw something elegant. What if light comes in packets? Fixed amounts of energy, indivisible chunks. What if a single packet either has enough energy to kick out an electron or it doesn't? Color determines packet size. Blue packets are bigger. Red packets are smaller. Shine dim blue light, few packets, but each one punches hard. Electrons fly. Shine bright red light, many packets, but each one punches soft. Nothing moves. Quiet. This was radical. Light as particles, tiny bullets of energy, each carrying a specific momentum. The old guard hated it. Light is a wave. We proved this. Interference patterns, diffraction, a century of evidence. Einstein didn't care. The constant is enforced. Energy comes in packets. Each packet carries momentum. The universe said so. This wasn't preference. It was accounting. 17 years later, Einstein won the Nobel Prize. Not for relativity, not for the famous equation, for the photoelectric effect, for proving light carries momentum in discrete bundles. Think about what just happened. The most famous scientist in history won his greatest honor by proving that massless light punches like a particle. So far we've learned light has 0 mass. Light carries energy in packets called photons. Each photon carries momentum, and that momentum is real enough to win a Nobel Prize. Now let's prove you can feel it. Picture this. You're floating in space, complete vacuum, nothing around you for millions of kilometers. No air, no friction, no gravity pulling you anywhere. Just you and a flashlight. You turn it on. What happens? Here's what your gut says. Nothing. Light leaves the flashlight, you stay still, light has no mass, no recoil, no kick. Wrong. You drift backward, slowly, incredibly slowly, but you move. Now watch what this actually implies. The flashlight shoots photons forward. Those photons carry momentum, momentum going forward, and momentum must balance. The universe keeps strict books. If momentum leaves in one direction, equal momentum must appear in the opposite direction. This isn't optional. This isn't theory. This is cosmic law. So you float backward. No exhaust, no fuel burning, no rocket propellant, just light leaving and you recoiling. Do this right now in your mind, Imagine holding your phone flashlight in zero gravity. Turn it on, you push backward. Turn it off, you stop accelerating. Point it the other direction, you drift the other way. Steering with light, exactly. This thought experiment isn't fantasy. Physicists call it radiation pressure, the pressure exerted by light. It's measured, it's calculated, it's used. People say you need fuel to move in space, but that's just a label. You need momentum, that's all. And light provides momentum, free, unlimited, as long as you have power for your flashlight. Here's where it gets practical. On Earth, you'd never notice. Air resistance overwhelms everything. Gravity pins you down. The flashlight's push is laughably small. But in space, no friction, no drag, no gravity well if you're far from planets. Tiny forces accumulate. A photon's push is small. A trillion photons? Still small. A trillion over months? Meaningful. And that's not theory anymore. That's engineering. Because someone looked at this thought experiment and asked a dangerous question. What if we built a sail? A giant mirror? What if we caught sunlight and rode it? They built it. It worked. May 21st, 2010, a Japanese rocket launches from Tanegashima Space Center. On board is something strange. No traditional engine, no chemical fuel tanks, no ion thrusters. Just a giant sheet of plastic thinner than a human hair, 14 meters wide, coated in reflective aluminum. Icaros, the world's first solar sail spacecraft. This is where it gets real. Icaros unfolds in space like a flower blooming in vacuum. That thin reflective membrane catches sunlight, and the spacecraft moves. No combustion, no propellant, just photons bouncing off aluminum. Beautiful. Here's how it works. A photon hits the sail, bounces off. When it bounces, it transfers momentum twice. Once when arriving, once when leaving the opposite direction. Double push. Billions of photons hit every second. Each push is microscopic, but they add up. Icaros accelerated, slowly, gently, relentlessly. The spacecraft reached Venus, powered by light. The universe doesn't care what feels right. It cares what balances. Momentum in, momentum out. Spacecraft moves. This isn't science fiction anymore. NASA launched their own solar sail in 2022. LightSail 2 from the Planetary Society orbited Earth pushed entirely by sunlight. They raised their orbit, no fuel burned. And now, NASA's Advanced Composite Solar Sail System is testing larger designs, bigger sails, faster acceleration. People say spacecraft need fuel, but that's just a label. Spacecraft need momentum. Sunlight provides infinite momentum for free. The sun is a limitless engine. You just need a big enough sail. Think about what just happened. Massless photons, zero weight, pushed a spacecraft to another planet. The same light warming your face right now? It's a propulsion system. We just learned to catch it. Light doesn't negotiate. It delivers momentum. Every photon, every time. The books always balance. Do this right now. Look outside. See sunlight hitting any surface. That surface is being pushed. Trees, cars, buildings, your own skin, pushed by massless light. But we're not done, because this same force, it holds stars together, and that's where everything gets cosmic. Now zoom out, way out. Look at the sun, a giant ball of nuclear fire, crushing gravity, pulling everything inward. Billions of tons of hydrogen squeezing toward the center every second. So why doesn't it collapse? Why doesn't all that mass crush into a single point? Light, dangerous. Deep inside the sun, nuclear fusion creates photons, trillions upon trillions every microsecond. Those photons carry momentum, and they push outward. Gravity pulls in, light pushes out. The sun exists in perfect tension, a war between collapse and explosion. Mass versus momentum. The universe keeps brutal books. Take away the light pressure, the sun collapses in minutes. Gravity wins. Everything crushes inward. Add too much light pressure, the sun explodes. Radiation wins. The star tears itself apart. Balance. Always balance. Here's where it gets even stranger. Some stars produce so much light that they nearly destroy themselves. We call this the Eddington limit, the maximum brightness before radiation pressure overwhelms gravity. Cross that line, the star sheds its outer layers, blown away by light, massless photons, ripping apart objects millions of times heavier than Earth. Simple. And black holes? Even black holes feel this. Matter falling toward a black hole heats up, glows, releases radiation. That radiation pushes back against incoming material. Sometimes the light pressure gets so intense it stops matter from falling in entirely. Light fighting gravity at the edge of space-time's most extreme object. People say light is gentle, but that's just a label. Light is force. Light is pressure. Light shapes the architecture of stars and the feeding of black holes. So far, we've learned light carries momentum. That momentum pushes spacecraft. That same momentum holds stars in balance. Now here's the real question. What does this tell us about reality itself? Here's where everything shifts. This isn't really about light having momentum. It's about what mass actually is. Let me say that again. You spent your whole life thinking mass is the fundamental thing, the real stuff, the substance of reality. Heavy objects matter, light objects matter less. Massless things are ghosts. That belief is backwards. Energy is fundamental. Mass is just one costume energy wears. Think about what just happened across this entire video. Light carries energy. That energy moves through space-time. Moving energy carries momentum. Momentum exerts force. Force moves objects. Nowhere in that chain did we need mass. Mass is frozen energy, locked up, sitting still. When energy gets trapped in a stable pattern, quarks spinning, electrons orbiting, we call that pattern a particle. We call that particle massive. But the energy was always the real thing. People say mass is solid and real, but that's just a label. Mass is energy that got stuck. Light is energy that stayed free. Both carry momentum. Both exert force. Both bend space-time. Yes, light bends space-time too. Gravity curves around concentrated energy, mass or no mass. The universe doesn't count grands. It counts energy. It tracks momentum. It balances the books with brutal precision. Reality doesn't care about weight. Reality cares about energy flow. Brutal. Your body right now? It's mostly empty space. Quarks and electrons separated by vast atomic distances. What gives you solidity? Energy patterns, electromagnetic forces, quantum fields pushing and pulling. You're not made of stuff. You're made of locked energy. Light just skipped the locking part. And here's where it gets uncomfortable. When you stand in sunlight, energy transfers to you. Momentum transfers to you. You are being pushed right now, always. Starlight that traveled for millions of years is depositing momentum into your skin this very second. Photons from distant galaxies, ancient light, still carrying force. You're connected to the cosmos by momentum. Light doesn't negotiate. It doesn't ask permission. It arrives. It delivers. The books close. The constant is enforced. So the next time someone asks how light can have momentum without mass, tell them they're asking the wrong question. The real question is, why did we ever think mass was required? Energy moves. Movement carries momentum. That's the rule. Everything else is just accounting. So here's where we land. Light has no mass. Light has momentum. Both statements are true. Both coexist. And that's not a paradox. That's the universe telling you something deep about itself. Mass isn't special. Weight isn't fundamental. The thing you can hold in your hand, just energy that learned to sit still. Light never learned that trick. Light moves, always, at the one speed the universe allows, and it carries momentum because momentum is what moving energy does. Done. Right now, step outside or look toward a window. Feel the sunlight. That warmth, energy arriving. That invisible pressure, momentum delivering. You are being gently pushed by a star 93 million miles away. You just didn't know it until now. The universe keeps perfect books. Nothing is free. Nothing is lost. Energy moves. Momentum transfers. The ledger always closes. Light doesn't negotiate, and neither does reality. So here's my question for you. If massless light pushes spacecraft, holds stars together, and transfers momentum to your skin every second, what else have we been wrong about? What other obvious truths are just labels we mistook for laws? Think about it and leave your answer below, because I suspect we're just getting started.